In this video, I will talk about polynomial inequalities. Before I start with the polynomial inequalities, I have to give you some quick tips for word problems. For example, I have the inequality sign. If you use fewer than x, then make sure your sign is less than x. This corner means less, the alligator mouth open is greater. At least x is going to be greater equal less. And if you pay attention, this means at least x. So x should have a small side, like a shorter side or small compared to the big one. So x has a small end or close end towards it, which is smaller. At most, it's going to be less equal x. At most. So do you see if the alligator mouth open, which means big, greater? So that's towards x. Then we have more than x. This means more than x, like x is smaller than, or x has less than whatever we have up here. So more is going towards whatever more we are talking about. Okay, so these are a few things that you should remember. Now, here we go with the examples, polynomial inequalities. We will solve inequalities like equality, like in equations, instead of the inequality signs. If you are solving something like an equation, it would be the same thing. Find the solution of inequality, and this is what the inequality is given. So what is the solution? Solution means I'm looking for an order pair like x and y. So how do I get that order pair? That's the simple way for this is make x plus 3 equal 0, make x minus 2 equal 0. This is the first step. X plus 3 equals 0, x minus 2 equals 0. Up here I'm gonna get negative 3, up here I'm gonna get positive 2 because I subtract 3 both sides and add 2 both sides. Like I moved the 2 to the other side of equal, moved the 3 to the other side of equal, and we used opposite operation. Now you draw a line. You have negative 3 and 2, so you have negative 3 up here on the number line and 2 is right there. So the easy way to pick the solution for this, you just make sure that pick numbers between the intervals and also plug in these numbers, the negative 3 and 2, also in the original equation. So the first thing, you make something like this equal 0. This one is already 0, so I don't have to do it. Now, most of the time, if it's harder equations or inequalities, then we graph them and we find these points like 3 and negative 3 and 2. But in this case, they were kind of easy. They already factored out, so I just have to make them equal 0 and get the answer. These are also called critical points. What is the critical point? You make both of the factors equal 0 in x equals something, and x equals something will give you the critical point. So plug in something over here, like for example, negative 4. So I'm going to plug in negative 4 in the equation and I'll see what I'm getting. Am I getting a true statement? Like it's whatever I get when I plug in negative 4, it has to be less or equal than 0. So let's plug in negative 4, and this is my scratch area. This is my scratch area, and I'm going to use red pen up here for the scratch. So plug in negative 4. So negative 4 plus 3, this is negative 4 actually I'm plugging in. Negative 4 plus 3, and then negative 4 minus 2. This is going to give me negative 1, and this is going to give me negative 6. Negative, negative, you multiply, you get some positive answer, right? And then positive answer, is that less or equal 0? No. So this thing, negative 4, doesn't work. So we're going to say negative 4 doesn't work. So you just put cross there. Now plug in negative 3 here. Okay, I'm going to pick any numbers between them, like the intervals, this interval, that interval, that interval, and also I'm going to plug in negative 3 and 2. So now plug in negative 3. So now I'm going to plug in negative 3. whichever makes the statement true, we're going to do the check mark. So I have -3 plus 3, -3 minus 2. If this is 0, then you know this is going to go 0 too. So I got 0 less equals 0. Yes, that's true. It works because 0 equals 0 too. So -3 works. Then we plug in something over here, which is probably pick 0 here. 0 is the easiest one. So go back there and plug in 0. When I plug in 0, I got 0 plus 3, and I got 0 minus 2. So this one giving me 3, this one is giving me -2. So I technically got -6, which is less or equal 0. Yes, it is less than 0. So this one works too. So this 0, that works. That works. Then we have a 2. Plug 2, like whatever between -3 and 2 is, it works. Now let's pick number 2. If I plug in 2, I'm going to get 2 plus 3, and I'm going to get 2 minus 2, which is less equal 0. Yes, because if this is 0, then we know that we're going to get the other number also 0. So yeah, the 0 less equals 0. Yes, that works. So the number 2 is also working. Let's try something, pick something here, which is 3. So I'm going to pick 3, and let's see if it works. I'm going to pick 3. 3 plus 3 is going to give me 6, and 3 minus 2 is going to give me 1 less equals 0. 6, and that 1 less equals 0. This is not true. 6 is not less than 0. So this portion doesn't work. So how do we write the solution for this? Between -3 and 2, everything works. It's check mark. And -3 and 2, both of them are also working. So my order pair reply, the solution is going to be, since -3 works, it's a defined point. So it's included, it's a bracket. You go -3, the smallest number goes always first, and then you have a 2 and bracket close. Why do I have brackets there? Because 2 and -3 both works for them. And another thing, you can see this is less equal. So for less equal, we have a closed circle, which means the brackets. So that's my answer for this question. Okay, let's try the next one. Example number 2. In example number 2, we have 0.3, and we have to x to the power, multiply with x to the power 5 plus x4 minus 12x cubed less than 0, and we are looking for the solution of inequality. Now this is, I can't factor out x to the power 5, like it's really hard. So what we can do, we're going to graph this 0.3 x to the power 5 and on y1, and we're going to graph 0 on y2 on the calculator, or if you don't have a graphing calculator, use the online graphing calculator or Desmos. So I'm going to go back to the calculator, and I will show you, this is how I typed in my equation, and in y2 I typed in my 0, and I'm going to graph that. Once I graph, the graph look like that. Now in this graph, since I'm looking for my critical points, like you can see the point of intersections for both of them. I can see the point of intersection. I have -4, 0, and this one is 3. Now there is a specific way to find point of intersection on the calculator, but I'm not using it right now for this question. For other question, we'll use it. Not for this one, because I can clearly see what my point of intersections are on the calculator. Like I don't have to use a specific method. This is -4, the one on the left, and then I have a 0, and then I have a +3. So these are all 3 my point of intersections, and we are going to plug in the intervals between them, and also -4, 0, and this 3 to see what we are getting, if we are getting the statement correct or not. So let's go back again. Let's go back again to the question, and here is the question. And according to that, since we have, first, you guys saw we got -4, 0, and 3. So I'm going to plug in -5 here first. I'm going to use -5 first. Then we're going to plug in here -3, up here 1, and that's 4. So I'm going to show you how to use a calculator for -4. So -5, and then on the calculator, and after that I don't have to show you how to plug in and do that. So the rest of them I will just do it and give you the answers. So plug in -5 first. Now I'm going to go back to my calculator. Now you guys can see on the calculator, if I go there, this is what I typed in for -5. I typed in -5. Now in -5, you can tell I got -300. Once I get -300, it means it's making the statement true because -300 is less than 0. So it's making the statement true. So for that, I have -5 is working for us. So -5 is working. Now we're going to try -4. -5 works because I'm getting -300 less than 0. That's true. Now we're going to plug in -4 in the equation and see if -4 works. So let's go back to the calculator. And this time I'm not going to make typing all that information again. I'm just going to go up there, enter, and I'll change every 5 to 4. I move the cursor like this, like I'm using these buttons for the cursor. 4, -4, negative was already there, so all I have to do is change the 5. Number 4. Okay, so here we go, 0. So if I get 0, 0 is not less than 0. It's supposed to be equal 0, but not less equal. So that doesn't work. So -4 is not working for us. If -4 is not working, then we can say that up here, -4, we got actually 0 less 0. That doesn't work. So this is not working. And this is exactly how I'm going to plug in -3. And I already showed you that -3 works because I'm getting some negative number for -3. I'm getting some negative number less than 0, -3 or -4, something like that. But it's a negative number which is less than 0 works. Then I plugged in 0, 0 doesn't work. 1, this is working, 3 doesn't work, and 4 doesn't work. So only the portion that works is from -infinity to -4, and -infinity is always parentheses because it's not a real value. -4 is not included because, you know, -4 didn't work when we plugged it in. The statement was not true, so -4 didn't work. So that's why we have these parentheses. Okay, if it was work and it was a statement making true, then we have a brackets. Then we have another one, -4 and 0. Between -4 and 0 works, but -4 and 0 not working. So I have a parentheses. Next one, between 0 and 3 works, but not exactly 0 and 3. That's why I have a parentheses there. So that's my solution for that inequality. Now let's find the solution for example number 3. If you check example number 3, this is my question, and I just moved the -10x and +6 on the other side of inequality and made it equal 0. Now I'm going to graph this again with the 0, and I will find the point of intersection. So let's see how we find these point of intersection on the calculator. So let's go back to the calculator. Now I'm graphing that. Go back to the graph. I'm clearing that, and I'm typing in 2x to the power 3. Move the cursor, plus x to the power 2. Move the cursor, minus 10x, and then plus 6. We're going to graph that. Now that's how my graph looks like, and we already got the 0. 0 was already there, which is in red line. You see that's red, and I have a blue graph. So this is how my graph look like right there. Now, what are the point of intersection? If you pay attention clearly, the point of intersection is this, that one, in this one. But if you can tell, they're not exactly going on the line. Like I can't say it's between -2 and -3. That one is between 0 and 1. This one is between 2 and 3. So in order for us to get exactly what the point of intersections are, I'm going to use that specific method that I talked about in the first question. You are going to go and click on this blue, which is second, and this calc, like this trace button, which it says the blue up there, calc. So this in calc, and you go all the way down to intersection, intersect, number 5, hit enter. Now up here it says first curve or second curve, or I mean the calculator is picking his own first and second curve. So I pick the first, which was blue, the second one is red. I click on the red, then I have a guess. For the guess, I would suggest just hit enter, don't do anything with it. So hit enter. Then my point of intersection, one of them is 0.732. So one of point of intersection is 0.732. I'm going to write down that somewhere. Now let's go and find another point of intersection. So again, I'm going to go second, calc, again number 5. And this time I'll move the cursor somewhere so I can get this point of intersection. So I would say enter, and enter, and enter again. And it gave me this intersection, which is 1.5. So it was 1.5, so I got that one. Let's try another one. Second, calc, again intersect, and now move the cursor close to that intersection so we would know what is going on in there. What is that intersection? So I'm not getting close to it, it's just leave it there, like not that close, and enter again. In intersection, this one is a -2.732. So that's my another. That's exactly the numbers for the point of intersections. So let's go back, and now we're going to plug these in the equation to see the statement is true or not, less or equal 0, and we're going to pick interval between them two. So let's try that. So I'm going to make a number line here for the critical points that we just figured out. Those critical points are -2.732, -2.732. Another one was 0.732. I don't know the exact spaces between them or anything. I'm just putting negative on this side, positive on this side, and this is 1.515. Actually, that one 3 decimal places. So we got all of this. Now we're gonna plug in the values there. The first one, I'm going to pick something here, like for example -3. If I plug in -3 here, it is making a statement true. I am getting less or equal 0, so this one is true. Plug in -2.732 in this equation and see if you are getting some negative number or equal 0. We are getting that, so that works. Then plug in anything between here, like for example 0. If I plug in 0 here, 0, 0, 0, 6 is less or equal 0. No, 6 is not less or equal 0, so this doesn't work. Plug in 0.732, it works. I am getting something less than 0, like a negative number. Up here, plug in probably 0.8. 0.8, this one also working. That works. I am getting something less or equal 0. 1.5 is also working. I am getting some less or equal than 0. And I think that's enough for this. So everything is working except this between them. So if I go and move on and write down my equations up here, so I would say I'm starting negative infinity, and it has to be parentheses. This -2.732, do you see I have a check mark on it, which means that working, like it was making the statement true, like less than 0 I'm getting negative numbers. So I'm gonna make a parenthesis, a bracket, sorry. Then between this and this is not working, so we don't have to write anything here, but from here to here it's working, everything working. Like 0.732 is bracket because it's working, and 1.515 is also a bracket and it's working. So this is, and this U means like they are together. So this is what the solution for the inequality is. Okay, let's do question number 4. In this question, number 4, find solution, and we have the same thing. So I graphed them. I graphed this whole function, and I technically got the critical points by using my, how do you find critical points on the calculator? I mean, sorry, point of intersections on the calculator. You just have to go to calc, second, and calc, like a second and trace button, and pick intersection and pick your graphs. Like the calculator will pick for you. Just have to hit enter, enter for the first curve, enter for the second curve, enter for the guess, and then enter for the answer. So this, in this one, I have a point of intersection, 2 of them, like 5, 2, 5, and I have 3.491. These are my 2 point of intersection on this graph. Pick something over here probably just pick 0 here. When I plug in 0 in here, you know this is 0, 0, 0, 0, 0, but 1 is greater than 1. That works. Plug in 525. When I plug in 525, I am getting some greater number, and it's greater than 0. And guys, if we use a calculator for plugging in all of this, like I'm going to plug in 525 for x to the power 8, 0.525 x to the power 7, 0.525 x to the power 6, and so on. If your number is greater than 0 or equal to 0, then you're good. For between them, I'm going to pick 1, and that doesn't work. When I plug in 3.49, it works. But for 4, I plugged in 4, it works. So only doesn't work between these two. So how do I write my inequalities here, or solution? I'm going to start negative infinity, not included. Infinity is always not included. 0.525, and since it works, I have a bracket. Then between them doesn't work, so I'm going to start right there. It's going to be bracket 3.491, and I have a positive infinity. Positive infinity works, but since for the infinity is not a real value, so we can't have a bracket, we can have a parentheses. So this is my solution for that. In case you have this question and you get all of the things works, like this one, for example, this is 1 and that's 2 and that's 3, like the point of intersection, that one works, this works, this works, this works. If everything works the whole line, then you're going to say all real numbers is working. So your solution is all real numbers. Okay, example number 5. Now for example number 5, for this is already factored out, so we don't have to graph it. The only graphing is the one we can factor out, and it's hard to factor out. So in this case, let's figure it out. I'm going to make x a critical points, means x plus 4 equals 0 and x minus 1 equals 0. So it's going to give me x equal negative 4 and x equal positive 1. So these are my 2 critical points. So I'm going to make a number line. I have negative 4 and I have 1. So plug in 5 here. Plug in 5 here. When I plug in that 5 in this equation, like 5 in this equation, then I got 5 plus 4. 5 plus 4, I'm sorry, negative 5, not positive 5. So negative 5 up here plus 1 is going to give me negative 1. Negative 5 minus 1 is negative 6, which is giving me 36, because it's a square. 6 times 6 is 36, is greater than 0. Is it greater than 0? No, because I'm getting negative 36. So negative 5 doesn't work. Plug in negative 4. Negative 4 plus 4 is going to give me 0. So it means this whole thing also turns 0. So 0 is greater than 0? No, that doesn't work. So negative 4 is not working. No, it's not going to work. Then we have up here is 0. So plug in 0 here, 0 in 0. So 4 times positive 1 is greater than 0. Yes, 0 is working because I'm getting positive greater than 0. That works. So 0 is working. Plug in 1. 1 plus 1. 1 plus 4 is 1 plus 4 is 5, and 1 minus 1 is 0. So that's 0 greater than 0 doesn't work. So 1 doesn't work. Then we have what else we have here? 2. Plug in 2. If I plug in 2 up here, then 2 plus 4 is 6, and 2 minus 1 is 1. It is greater than 0, so that 2 works. So that's my solution. Like, I'm going from -4 not included, 1 not included, because between them it works, so I'm just not including them, and 1 is not including, but infinity I'm going and it works and it's not included. So that's my actually answer for the question. Now, in case they said graph that, how do I, sometimes they, instead of this multiple choice like these solution, these order pairs, they give you graph. How do I graph that? So I'm going to show you how to graph that. I will say, okay, -5, -4, I'm just making a number line, -3, -2, -1, 0, and then I have 1, 2, 3, and 4. Okay, so you check x equal -4, which was not included, so it's going to be open circle. Let's make it a different color. So that's an open circle. On 1, I also open circle because that doesn't work either. So 1 is open circle. There you go. So I'm picking something like I'm starting, negative infinity doesn't work, from -4 to 1 works. So -4 to 1, I'm going to make a line right there. From between -4 and 1 it works. From 1 to infinity it works. So this is 1, and I'm going to go all the way to infinity works. So this is the graph of this example number 5 looks like. Whatever works, you're going to draw a line there. Whatever doesn't work, you don't do anything there. Okay, so let's do example number 6. Move the 10x to this side of the inequality, and then that one turns 0. So this is how you're supposed to get every time. You have to make sure you have a 0 on one side. Now we are going to graph this. Let's go to the calculator. Now in the calculator, I already have that function there, 3x cubed minus 2x squared minus 10x. I plugged it in here. And then I have another one, y equal 2, which is right here again. Now we're going to graph this and see how would it work. We need to figure it out, the point of intersections. So here's my graph, and see, here is the graph. I'm going to make it really close to it so you can see it. Now, in this case, if you pay attention, I can see the intersections right there, like very clearly. So we have to use that strategy to find the point of intersection. How do I do that point of intersection every time? Make sure that you understand and write it down if you don't know. First, you have to click on the second and this trace. You go to number 5, which is intersect. Then the calculator is picking their own, they are picking their own curves, the first curve. It says the first curve, so it just came the blinking thingy on the blue. So that's my first curve. When you hit enter, it moved to the second one, which is the red one. Again, we hit enter, we don't do anything. And it says guess. After guess, you enter one more time, and it's going to give me my point of intersection. In this case, the point of intersection is -1.5225. So this is my point of intersection right there. Now that's my one point of intersection. Now let's do another one. Again, you do the same process 3 times, because I can see I have 3 point of intersections for between the red and the blue graph. So hit second, trace, number 5. Now this time move this blinking thingy to that, because we know that one is 0, 0, so we don't need that one. We already are sure on this one. So let's get close to that point of intersection. Hit enter, enter again, guess, enter again. Now this time your point of intersection is 2.189. So I got 3 point of intersections already, which I'm gonna make a number line, and we're gonna go back and plug in everything. So let's go back there. Now my point of intersections were, we had negative 1.5, we had 0, and then we had 2.89. So I have 0 in the middle, I have negative 1.5, and I had 2.189. So this is what I got so far. Now plug in, pick something here. I'm gonna pick here negative 2. So plug in negative 2 in this function and see if the statement is correct. So I'm gonna plug in 3 negative 2 cubed minus 2 negative 2 squared. This is negative 2. And minus 10 negative 2 again, and greater or equal 0. So I'm gonna plug this in the calculator, and then we have to go back to the calculator, and I'm gonna see how this works. So I'm plugging in. This is another question, so let's try that. We have 3 parentheses negative 2. We just have to plug it in once, and then after that we have to just copy paste and do the stuff. Then we have minus 2 parentheses negative 2 to the power square, and then I have minus 10 negative 2. Oh, I think I messed up because I didn't move the cursor. So move the cursor again, then I have minus 10x. Minus 10 negative 2 parentheses, and I think that's it. So you enter. It's going to give me negative 12. Negative 12 means it's not greater or equal 0, so that negative 2 is not working for us. Okay, so I'm writing it down somewhere. Negative 2 doesn't work. Now let's try plugging in negative 1.5, because that was the next one. So I'm just gonna use this, move the cursor, enter, and change everything to negative 1.5. 1.5 parentheses. Let's go back again. Negative 1.5 parentheses. Go back again. This is kind of really easy, not to type in all the stuff again, and hit enter. Now this is 0.375, which is greater or equal 0, so negative 1.5 works. Now we're going to try the number between negative 1.5 and 0, which was negative 1. So this is how we're going to do it, and I already have the rest of them plugged in, so I'm going to give you the answers, but I just wanted to show you how this works. Now let's see. We already figured it out that negative 2 is not working, because for negative 2, what we got is negative 12, which is not greater or equal than 0. So that doesn't work. That's a big no-no. So this is not working. Then we plugged in negative 1.5, like 3 negative 1.5 cube minus 2 negative 1.5 square minus 10 negative 1.5 greater or equal 0. Now this time from this we got 0.37, which is greater or equal 0, so this one works. So this one doesn't work, negative 1.5 works. Now in the middle up here we plugged in negative 1. When I plugged in negative 1, it's working. I am getting some numbers which is greater than or equal to 0, so that one works. When we plugged in 0, it also worked. Like, look, 0, plug in 0 here, 0 here, 0 here, so 0 greater equal 0. It's not greater, but it is equal, so this 0 works. I plugged in here, for example, I picked what number we should pick. 1. We picked there 1, and that 1 doesn't work. Now this 2.1 189 works. This one also works. So now how my functions goes, how my answer goes. Now in this, some of the questions, like we did the order pairs, like we just write it down the order pairs like that, like the -4 and 1, like, and not order pair like as in x intervals, like these are the x intervals. Now there is another type of way you can write the answer, and I'm going to show you that. For example, for this question we have a, and I'm writing that -1.5 greater or equal x less than 0, or you have 2.18, and these are your multiple choice answers that we're going to pick something there, less than infinity. Part B, it says -1.5 less equal x, and then this is greater than 0, or 2.189 greater or equal x, or less than infinity. Part C, I did -1.5 less equal x less than 0, or 2.189 less equal x less than infinity. Now we're going to check what our answer is in this case. So let's look at the number line. These are my choices, my multiple choice answers, but let's pick the answers from here. So I'm just gonna cross that, and let's see that. I starting -infinity to -1.5, but you know this doesn't work, so I don't have to write that. I'm gonna start directly with -1.5, and I'm gonna show you exactly what we did for the, like writing it as an order pair thing, like an x intervals. So this is -1.5, and it's a closed, it's a bracket because this one works. Then between this -1.5 to 0, 0 is also working, so closed. Then from 0 to 2.189 doesn't work, so we don't have to mention that. Then I'm starting with 2.189. Why do I have a bracket for 2.189? Because it's included, it works. And then I have a positive infinity, and infinity, whether it includes or not include, whether it works or not works, infinity is not a real value, so we have to put this parentheses, not bracket ever. So this is what I got so far. Now pay attention which answer would work. This one said -1.5, the x is less or equal -1.5. Do you see this is less? It's x less than -1.5. X is no, x is not less or equal -1.5, because less than equal means this portion, and it's not there, it doesn't work. So I already got the answer for that. I mean, I already decided about part A, answer A, because it's not working, because it said I only pick this portion of the question. If that question would work, I will move on and check each one of them, but let's figure it out, this one. And you read always from the variable side when you have inequalities. It says x less equal -1.5. You know, x less means everything up here less than -1.5. This is less 1.5, and this portion doesn't even work, so A is not our answer. Let's go to part B. Part B said, I'm going to just pick this one first, okay? X greater equal -1.5, and it says x greater, yes, because on this side, greater than -1.5, everything works. Now I'm going to check again this one, x greater than 0. X greater than 0 not really works, because look at that, greater than 0, this portion doesn't even work, so I can't say that. I can't do that. So this one is done. Let's try the last one. They said I'm picking this portion first. So x greater equal -1.5. Yeah, x greater equal -1.5. Greater than -1.5 works. X less than 0, less than 0 is this portion. Like I'm going in this direction, and I'm greater -1.5 going in this direction. So yes, between both of them, it works. So this portion done is good. Let's try that one. 2.189. Okay, let's try this first. X greater equal 2.189. Greater than 2.189? Yeah, it does. And equal. Look at this equal sign. So yes, this thing works. So this, everything works here. Now what? And in this case, x less than 0 Yeah, that was true. Okay, this one 2.189, x greater equal 2.189. Yes, greater works. Does it work here too? X less than infinity? Less than infinity like means this side, like this is infinity. So is this side works? Yes, that works. So our answer is C. Let's translate this first. They said cube of a number. For number, we can use x, cube of a number. So this is cube of a number is less equal than 3 times the square of the number. So it's just like that. And the question is asking what is the solution? Find the solution for it, like x values, intervals. So first thing first, we have to move the 3x squared here, and we do less equals 0. I'm going to graph this, and then we will see what are our point of intersection between 0 and this function is. And those point of intersection is my solution. So let's go back to the calculator. Now, you guys can check on the calculator. I already plugged in x cubed minus 3x squared, and I already plugged in 0 here. Now, I'm going to graph it. Once I graph, you guys can clearly see it's a 0 point of intersection, and 1 is right there, it's 3. Now, I'm not exactly finding and using my menu and second and calc and stuff like that because I can clearly see up here. So it's 0 and 3. So my intersections are 0 and 3. So in 0 and 3, so that's my solution, like a x value, what they were asking me, that's the solution for it. So it's 0 and 3 as an order pair. And 0 is also included, and 3 is also included because I can see they are closed intervals. So example number 8, let's try this question, word problem. Monthly salary of the teacher can be modeled by the function x is the number of the years of employment. After how many years teacher will be able to get $10,000 per month. Now, how many years teacher will be able, that's the x that we are looking for. What is this 10,000? That's the dollars per month, and you know monthly salary is the function. So this 10,000 is f of x. So I'm going to write my function. It's 2x to the power 4 minus 5x squared plus 5,000 equal 10,000. Now I'm going to graph this, and I'm going to take you to the calculator, and it's not going to graph. You won't be able to see it because 10,000 is a lot of, it's a huge thing. So the calculator can't do that. But even if we do the find intersection on the calculator, it will give us intersection, but it's just the window is really small. We won't be able to see it. So let's go to the calculator. Now in the calculator, I already typed in my function like the 2x4 and all that function in 10,000, and I'm going to graph it, and you see there is no graph there. I can't even see the graph. Like, it doesn't mean the graph is not there. The graph is there somewhere, but the window is small and we can't see it. We can still find our point of intersection for the x. Like, I can find my x value. So I'm going to go second calc and intersection, the 5, and enter. And you see it says first curve. I don't see anything there. And even if we see the graph, I showed you guys this before, the calculator is going to pick first and second curve. So I'm just going to hit enter, enter again for the guess, enter again, and intersection is giving me 7.16. So it means if I round it up, I'm going to go back to the question. If I round it up, you can tell after 7 years, like it's the x value is equal 7.16. So it means after 7 years, the person will be able to make $10,000 per month. The teacher will be able to make it. So you graph it both sides and find point of intersection. And I showed you guys several times how to use a calculator on that. Example, the last one. This one said the width of the rectangle prism is 3 less, so I'm going to write down everything in math. The width is equal 3 less than the length, and height is twice of the length. Volume is 400 cubic units. Then they are asking what is L. Now I know the volume formula for the rectangular prism is length times width times height. I know the volume is 400. Length we don't know that, but the width is L minus 3 and the height is 2L. So I'm gonna do L squared minus 3L. I multiply and then we have a 2L. Now I'm gonna distribute one more time again. 2L cube minus 6L squared. And I still have that 400. Now I'm going to graph this and we will find point of intersection. So when you graph in point of intersection, you're going to find. So graph one, y2 and y1, graph them, and you find point of intersection, which means that's going to be L. So your L is 7.04. You guys can do and use a calculator on that one. If you guys have any